Okay, so good evening once more again. Um, if you can hear me, just do a thumbs to be sure we are together because we are going to be starting this class right away. Yes, so I will be taking attendance today. Uh, uh, as we proceed, I will drop the link to the attendance sheet so that we'll be able to get your details and know who have been with us from the beginning to this. For yesterday, you guys are lucky you have it as a first. So yes, so thank you very much. Uh, the two topics where what we'll be looking at. Do I have to introduce myself? I'm still the same person that yesterday. So my name is Samaila Anthony Malima. Um, a lead ambassador with Alchemy University, also a Web3 developer advocate, also an ambassador with Web3.js, a lover of decentralized application. So today we are still in the areas of the theories that we're trying to look at what this technology called blockchain is, and today we'll be looking at the blockchain mechanics. So, and in this module, what you are expected, you will be diving into the mechanics of blockchain technology. We'll look at some details explanation of its fundamental components, cryptographic principles, and then consensus mechanisms. By understanding this concept, so it's expected that by the end of today's class, you have a understanding of blockchain achievement, decentralization, security, and transparency, right? So yes, so like we discussed yesterday, we talk about blocks, chains. We talk about the ledgers. So those are the basis. So today we will be looking at, we'll be going more deeper how blockchain works, how these blockchains we call the name that we've been talking about since yesterday, how this blockchain works, blocks, transactions, and then the hash it. So blocks. So we'll look at blocks and then we'll try to see what the definition of block is, and then see how we relate to everything we do. So like yesterday we talked about blocks. So block is a container that holds transaction data and metadata, right? So when we talk about data and metadata, we talk about example of data that this block holds, is timestamp and hashes. So timestamp, we're looking at the time at which this particular block or this particular event took place. So block is able to record all this information for you. Then we'll be looking at the component where we'll be talking about the headers. Headers are containers, contains metadata and such as the timestamp record, previous hashes, then the norms, right? So when we talk about timestamp, like I said, it records the time or the period at which these blocks are created, while hashes is a cryptographical where in a chronological order. When you create block A, the next block that is created it follows. So this is what we are talking about hashes here in this. So variables, that's nonce. Nonce is a term in blockchain that is known as a variable number, which is used for mining these valid hashes. Then data section, we say data section is a store of batch of verified transaction. Then hash as a unique cryptographical, the footprint or the fingerprint of these blocks, right? So I just want to show you how these blocks look. Let me refresh this and see, because we'll be able to. I just want to show you how some of this block look. Yeah, so okay, sorry. Let me see. So blocks in blockchain. So wait. Uh, I just want to show you guys how these blocks look like. I wanted to have a clear graphics that you'll be able to see, but here we should be able to have a hem. So can you guys see my? I believe you guys can see my screen clearly. So this is how blocks. This is how one block is created, right? So you look at it. This is how explanation of data are created in when creating a block. You see hashes, you see the previous hashes, that is the hashes. So if block A was the first block that was created, when you create block B, so there will be a hashes that it's going to number this and the time that this next block was created. So it will be recorded. So by tomorrow, next tomorrow we'll see how we are going to record hashes, create hashes, and then next tomorrow I will see we'll be able to create our own wallet, and then get some Etherscan. Then we'll be able to verify data on the Etherscan, right, and see how this block, the time they were created, and all those things. I will be able to show you tomorrow. Yes, so that's what I was trying to show you on that. Then transaction, um, in transaction is defined as a record of data transfer. So in a good example is in cryptocurrency and contract. So contract, not the house contract or the or your employment contract, but we're talking of the smart contract. Smart contract, which is the programmable logic that is created in order to manage. So all those your employment contract is an agreement, right? And also your house contract, all those things are agreements. So now when you write it in a programmable logic, so this is where it's called a smart contract. So that's where this particular transaction, it's record all those data in contract. So you can write it in such a way that all the data that is being collected will be able to record on that particular smart contract. So which is cryptocurrency and contract between two parties. So some of the key elements of transaction is, for you to carry out transaction, you know that you are going to send, right? That's sender and receiver's address, which is your public address. So the address I will send to you. Let me see, who am I sending an address to? Okay, Emmanuel. The address Emmanuel sent to me for me to send him some token or some money. It's called that. That is because Emmanuel has to have a receiver's address, and also I have a sender address. So that's what I wanted to just explain using Emmanuel. Then the amount being transferred, right? The amount I want to transfer it to Emmanuel. Then the signature of verification. So signature verification here is not the one you write with your hand, but there is another public key, a private key, that it's the one in charge of controlling or verifying that, yes, of course, Malima want to send Emmanuel something. Sure, is Malima having some money that will be able to grant this, then the private key will be able to validate that yes, of course, Malima have so amount and you want to give Emmanuel that particular amount. Yeah. Then verification. Transactions are verified by networks node to ensure validity and to avoid issues like double spending. So the issue of double spending in the sense that I don't know whether if you have ever experienced whereby um, uh, they send you money, somebody send you money, and then the money happen to go twice, right? So this issue of double spending has been settled using this particular transaction carried out in the blockchain. So issues with double spending cannot happen because it has to validate any transaction that is going. It has to validate and pass through all that. Yes, of course, I actualized that transaction. Then hashes, we've talked about hashes, and then is the process of converting input data into a fixed length string using a mathematical algorithm. Then character of hashes, they come in a form of deterministic. Same input always result in what? Same output. Then in irreversible, cannot deduce the original input from the hashes. Then avalanche effect. Small change in input will produce a drastically different output. So tomorrow we'll look at how if let's say Malima, whereby I remove or I add dot to the last name of Malima, you will see how the entire hashes of that name will change. Then importance of blockchain, ensure data integrity, and then links blocks securely by hashing previous blocks. So we'll also look at graphic cryptographic principle, hash function, and then digital signatures. So these are some things that we it's we have been talking about, so it's just like a repeated tautology, but I will be sharing this at the end of this class so that you guys will go back through it and then read over it and have an understanding, right? So a good example of input in blockchain, let's say input as blockchain, right? So when you input blockchain and you are going to have an output like this, you can see my screen, output like this, and this is a SHA-256 hashes. So SHA-256 is a principle of this algorithm that is written. So when you want to go deeper in so understanding cryptographic uh, technology, or you want to go into core blockchain, core dev, you will get to understand a lot. You need to read more about hashes because they are core concept, they are things, they are topic of their own that you will focus on to understand very, very well. Because if you, as a core dev, sorry, I'm not talking to developers, but as a core dev, they are not much in the environment, but they are the ones that make the highest decision. So you have to understand in-depth mathematical algorithm that happen during all these things. Then we talk about digital signature. So here a cryptographic mechanism uses to verify the authenticity and integrity of message or transaction. So let's say if I want to greet somebody, I like using example. I want to say hello. Hello, a blockchain don't understand that word HELLO, right? So after I initiate that hello, it will hash that particular word and change the entire system into a cryptographic hash that my signature will be able to have a clear understanding of it. Is anybody trying to say somebody's mic is on? Please, can you mute your mic? Please, if you know you are not talking, mute your mic. If you want, Amechi, please mute your mic. Thank you. So, sorry for the break in transmission, right? So, please always check your mic so that you will not distract us. So how this works, right? I've made mention of private key, which uses a signed transaction, and also public key, which uses a verified signature, right? Public key is the address, is the key you can send to anybody to send you money or send you anything or send you an NFT, but you don't send your private key to anybody. This is even if it is a test wallet, right? For testnet, you don't send your private key to anybody, because your private key, if I have your private key, I'll be able to have access to your wallet. So it's very, very important to note that you don't, it's just like giving your key to your house to someone, right? So that's that. Then process sends senders sign the transaction with their private key and creating a digital signature. Receiver uses the sender's public key to validate the signature. Then importance, it prevent tampering with transaction. That's one good importance of blockchain. Then confirm transaction are genuinely from the claim sender. So good example is a transaction signed by Alice, like I said here. Alice private key can only be verified with Alice public key, not that one. If there's anything you can take from this part, is that Malima's transaction, any transaction sent by Malima, will only be verified, will only be assigned by Malima's private key, and the public key of Malima will be the only key to verify that. So we are going to look at consensus mechanism. So consensus mechanism, it is, I will use this word, a upgrade from the initial Ethereum to the, that's Ethereum 1.0 to the Ethereum 2.0. So in 2.0, we were looking, we consider it as a proof of work. It is the amount of work you've done that you'll be given reward for. So proof of work here, while in the 2.0 is proof of stake. So in proof of work here, definition, a consensus mechanism where nodes the node solvers, that's the people validators, people that validate, that's the nodes, solve the complex mathematical problem to validate that particular transaction you want to add to the block of that entire this thing, because we have a node that validate everything, right? So, and this happened during new block creation. A lot of other computer servers all over the world would have to compete in verifying that. So the person that perform the highest computation take the reward, right? So, but everybody has to validate it. Then key features is computationally intensive and it requires significant processing power. So higher energy is required during the proof of work. Miners compete to solve the problem first and add the block to the main destiny. Then security, it's prevent tampering by requiring sustainable resources to alter the chains. So some of the challenge here is that there is a need for a higher energy intensive and environmentally costly. So this is some of the advantage. And also the transaction are very slow. Then good example of this is the Bitcoin consensus mechanism. So proof of stake. So here the consensus mechanism where validators are chosen based on the number of coin they hold. The previous one is based on who first perform the solve the computation, the mathematical computation. But here is the person that hold the highest number of coin, because you have to stake something to become a validator in POS. That's proof of stake, and are willing to lock up as a collateral in case something happen. So if validation is taking place and your system is down, you will be queried for that. So as a validator or as a node operator, you have to keep your system running up and running all the time, 247. So that is that. But if it happened during things where happen that it happened that your system is down, you will be penalized. Then key features of this is energy efficiency compared to proof of work, and validators are randomly selected to validate the transaction. Then incentive structure, validators earn reward based on their stake and participation. Securities reduces the risk of attacks, and malicious validators will need to control the majority of the stake. So good example is Ethereum move to proof of stake with the Ethereum 2.0 upgrade. So these are some of the good comparison. You see, for energy in proof of work, there's high energy. In proof of stake, low energy consumption. While validation process mining are use computational power, while here are random validators are randomly selected. So scalability here in proof of work is limited, while in proof of stake is improved. Security robust but reduce heavy. Here security is secure and cost effective. So yes, so basically that's why I always try to have my course content just as short as so that we'll be able to have an interactive section and then answer questions. So thank you very much, and then now it is time for us to respond to everyone's question. So if you have any question, please you can shoot. Thank you. Was I talking to myself?
Yeah, it is, sir. It is.
Okay.
Yeah.
So if you have any question, you can ask your question. No question for today?
Okay. Good evening, sir.
Yes, good evening.
So my question is this: this validator you are talking about,
Yes.
is he is he a machine?
Yeah,
Like
so okay. Yeah, okay, go ahead, go ahead.
is he a machine? Because you said the validator needs to solve a complex mathematical problem, and I don't know whether it's like in normal computer or like I just need to know more about the validator. Like I'm confused.
Okay. Yes, thank you. Thank you very much. Okay, I'm trying to bring everyone's on the screen so that we'll do a screen share. All right. So yes, so you talk about your question is the validators machines, right? I just want to confirm your question.
Yes, I was asking like the validator you are talking about, is
Mhm.
it same thing with because I don't like with nodes the
Okay.
or
Yes.
is it different? I don't
Oh,
know.
okay. So um, validators or not operators mean the same thing, right? So, but what I'm trying to explain to you is that for every transaction or block to be created, right? So there is a need for node operators or validators. Let me use that word, because it is the node operators or the validators that solve the computation, complex mathematical computation to verify whether this particular transaction that we are trying to add, that's the block they are trying to create, they have to validate, checking both the owner, that is the senders, and the sender's private key. Does the private key, is the private key of this sender qualify to initiate this transaction? If yes, then the public key of that sender has to verify it, and this can only be done by the node operators, that is the machines, the let me, I don't even know, okay, the machines, that's the machines that are running, that are running, and this node operator are checking it in order to make sure that their system are not down. You understand? So validators are the same thing as node operators, because it is during the verification of the node that block have been is allowed to be created. So the person that is qualified to create that block that you add to that particular network is the person that will be rewarded. And I will talk in proof of work. It is everybody will come, but depend on who's has the capability to carry out that particular transaction. That is, he has, because there's high power consumption and everything, energy and everything. While in proof of work, it's randomly selected. Let's say if we have about 2 million node operators, so the network randomly select from them, and these people validate this new transaction coming, and then once they validate is okay, is allowed to create, then the network will allow to create the add the transaction into the network. Okay, yeah, yes. Somebody is asking question. I just want to share something with you guys. Okay, anybody talking?
Good evening, sir.
Okay.
All right.
Good evening, sir. Sir,
Okay.
please can you give us like examples of proof of work and proof of stake? Because
Okay.
I don't really get.
Okay, example of proof of work, right? So in Ethereum 1.0, it uses proof of work. So let me go back to this my note. Okay, in proof of work, right? The good, we said that the consensus mechanism happen when the nodes, right, solve the complex mathematical problem to validate the transaction and create a new block, right? Here, it is all the node operators are eligible to perform in solving this complex mathematical problem to validate if the transaction that is about to be created is valid, qualifies. While in the proof of stake is that here it depends on the number of the validators are choosing based on the number of people that have a particular, they have a stake. Let's say you have a share. So let me use like a stakeholder, right? People that, let's say a company has a stakeholders, people that has a larger share, right? So if something they want to decide on whether they want to buy any another company, One person or CEO cannot decide that, oh, since my work is going well, I will just go and buy that. No, right? So here it's based on the, imagine somebody has 50% of the share of the company, and the rest of the people have 10%, 10%. So if even if they carry vote, they do election, the person with 50% has already won the election, right? So because here, so this is what actually happened in proof of stake. So, and you are willing to lock in, you are willing to invest as and put in that your stake without taking it out. So some of the good example, like I said, here in when it comes in time of energy consumption, in proof of stake, it has a low energy consumption, while in proof of work, it consume high energy. I don't know whether if I do justice to that. Did I answer your question? Onifade. You hear me? So
Yes, but
okay. So I
are
share
there like examples to differentiate them?
no. Okay, I share a link of a form on the chat, and I want everyone that is here. I want to get 23 attendance right now. So fill in the form. It's just your name and your email address that I need. So, and you guys, I believe you guys can do that. So before we close, we are not going to spend all our classes. We are not going to spend nothing more than 1 hour. So I want to be fair. If there's anything to assist anybody, right? So sorry for that. So I just want to bring that to you guys' attention. I post the link, the Google form, on the chat. Thank you.
Yeah.
Okay.
So you said improve or stake.
Yeah.
The person with highest stake,
Yeah.
validation goes to the person. So what I'm saying now is, does it affect the decentralization or the, what is it called? That is, in blockchain you said no one has the single autonomy of the whole, or like has the finance, like is they share something. So what I'm trying to know now is, in that proof of stake that you are saying that work goes to the, or validation goes to the highest stakeholder. Does it mean I don't know whether you understand the question.
Okay, I understand your question. So yes, so if you really understand proof of work, when you are solving, when they say it, the person that is qualified to create or to add a transaction into the network, it is the person that solved the complex mathematical problem, right? While in proof of work, says that people that are qualified to perform the validation are people that has stake and are willing to lock those stake, and they are chosen randomly. You may have the stake and everything, your machine may not be chosen to perform the validation, right? But because your machine is on operation, because your machine is running 24 hours, you still earn some share of that particular transaction, because every qualified transaction that is added to the block, that's the reason why there's for you to perform a transaction, you pay some gas fee. So this particular gas fee is what is shared for the people perform that particular calculation to validate that yes, this transaction is okay, let's add it. Not that these are not people, they are machines owned by different node operators. Do you understand?
Yes, sir.
All right. So Noah, your hands is up. Noah shoot, then Narcissus. Noah, if you are here, if you can hear me. Okay, Noah cannot hear me. Narcissus, can you hear me?
Yes, good evening.
Good evening.
Yes, I want to know if for the consensus we only have uh, proof of work and proof of stake.
Come again.
Yeah, I want to know if you only have proof of work and proof of stake as consensus. Do you have other consensus?
Okay. Other consensus happen in other networks. So the consensus, the proof of work and the proof of stake happen only in Ethereum network, right? So if you go to Solana, you have a different validators, consensus algorithm, but they have different name, but they are performing this almost the same thing, just that there's a little tweak of the way they do things, but they do almost the same thing. I don't know whether if I answered that question. So we have Ethereum, we have Solana, we have Avalanche, we have Optimism, we have Arbitrum, we have a lot of all these different network, right? And then even in Bitcoin itself, it has a different consensus algorithm, right? So that's how it is. So I don't know whether if I really answer your question right. Thank you.
Okay, thank you, sir. But uh, what you say now is about Bitcoin. We have different consensus in Bitcoin. For me, I thought that it's only proof of work you have in Bitcoin. So if you can explain it to me, it will be good.
Okay. Yeah. So is somebody speaking? Is somebody speaking?
I don't think so.
Yes, sir. Carry on, sir.
Oh,
Carry
oh,
on, sir.
all right. So for proof of work, yes. Even in my note, I give an example, which the example of proof of work here I said Bitcoin consensus mechanism, right? Right. So yeah, so and then in proof of stake, Ethereum moving from move to proof of stake with a 2.0 upgrade, right? So that is, I believe, if you were paying attention, I might have mentioned this earlier. So yes, so you are right, but even Bitcoin as a network itself, a lot of upgrade is coming. Then before, people don't have opportunity to build on top Bitcoin, but now you have opportunity to build on top Bitcoin. So that's how the upgrade happened. But I've not have gotten opportunity to sit and look at read in depth on Bitcoin, how their technology happened. So my area of focus is Ethereum because I'm an Ethereum person. Thank you. I hope I've made that clear. Thank you. Noah, I think your hand is up so that we can call it a day. 45 minutes max. That's the time I said I will close in today's meeting. I believe almost everyone has attended to this form, right? Noah.